My name is Werner Tepe and I'm Training Manager at the Eaton Experience Center Training. This video shows how to configure a drive from the RAMO5 family using the drivesConnect software. The software is started by double-click on the drivesConnect icon. The application components are loaded and it is checked whether updates are available for the device firmware files and for the drivesConnect software. If the message ready appears, the parameter editor can be started via the upper button. The next window is a request from cybersecurity and must be answered with OK. If cancel is selected, the software drivesConnect closes. The window size is then maximized. When the drivesConnect software is started for the first time, a DC1 device from the PowerXL family is shown by default. If a device from the RAMO5 family is generally to be displayed here, this can be done using the Add Virtual Drive button. As an example, the drive type reversing starter RAMO5W is selected. The firmware version is preset to 104, the operating voltage to 400 volt and the power rating to 3 kilowatt. The selection is confirmed with OK. The factory set device DC1 can now be removed from this list via the context menu with the right mouse button via Remove Drive. Afterwards, the RAMO5W can be set as default device in the same way via the right mouse button. The next time drivesConnect software is started, the RAMO5W will automatically appear as the default device. There are two ways to select the communication. Either via Tools, Select Communication Device, or via the Set Communication button. There are now several ways to establish communication with the drives. One is the serial interface as a wired version DX-CBL PC3M0 here via the USB port COM16, or the DX-COM Stick 3 with a Bluetooth connection. The DX-COM Stick 3 can be connected to the PC in two ways. On the one hand with the supplied dongle, which here offers the corresponding port COM8, or on the other hand via a Bluetooth connection with the Bluetooth capable PC. Then press the scan button. An available COM stick is displayed. The COM stick is selected. Then the connection is established with the Connect button. In this example, the bin code is set to 123456 and confirmed with OK. There are two ways to configure the drive. Change all necessary parameters, then transfer the complete parameter set to the selected drive. Or, in real-time edit mode, transfer the parameters directly to the drive. For this, it is necessary to perform Scan Drive Network at the bottom left. Up to 63 drives can be queried. In the factory setting, 8 drives are queried. The addresses are not identical with the ASI addresses. They are addresses of the OP system bus. drivesConnect searches the network for drives, which is displayed at the bottom right. From the drives found, all parameters are transferred to the drivesConnect software. In this example, one drive is connected. At the bottom left, the real-time edit mode is activated, which is then indicated with the green flashing LED at the bottom left. As an example, a motor with a rated current of 0.8 amp is used here. The message appears that the DXCOM stick is not yet unlocked. The red lock symbol still lights up on the DXCOM stick. Unlocking is confirmed with yes. Alternatively, the DXCOM stick 3 can be locked or unlocked by touching the lock symbol with a finger for a longer period of time. The next example is to configure a locked manual and automatic mode via sensor I1. This means as soon as sensor I1 delivers a high signal in manual or automatic mode, the drive is stopped. For this function, set parameter 113 to 4. If further settings are to be made, the access key must be entered. By default, as shown here via the tooltip, 101 is to be entered. Further parameter groups are automatically displayed at the top. Various parameters are visible in the monitor group, for example, the status of the sensor inputs, the error register with the last 4 errors, the firmware version of the drive, the serial number. In group 2, for example, the reaction of the RAMO to a thermistor error can be configured. In group 3, for example, the logic of the sensor input can be changed. By default, the sensor input is configured as a normal open input. By changing the logic, the sensor input can also be operated as a normally closed input. It is also possible to set the delay of an external mechanical brake during release and closing, for example, to prevent the drive from slipping when starting or stopping. Group 5 enables the configuration of a field bus, for example, for Ethernet IP or Profinet. This group is not of interest for ARTI communication. In Group 6, the phase sequence of a motor can be changed. In application where the direction of rotation is critical, this option should not be used. For example, if the drive has failed and this parameter P608 is not changed when replacing it, the motor could be driven into a mechanical blockade when restarting. Therefore, the recommendation is to achieve the correct phase sequence by swapping in the motor cable. Note, all parameters different from the factory setting are shown in blue. The respective parameter group also has a blue background. To demonstrate the setting, deactivate the real-time edit mode and call up the data logger. Presetting has already been made here with recording of the motor current and the sensor input 1. Start the recording. Now the key switch is turned to the right to manual mode. The selector switch activates clockwise rotation by turning to the right. The FED LED indicates this with a steady light. When the sensor input E1 is actuated, the drive stops. The FED LED flashes to indicate this. A restart via the selector switch with the same direction of rotation clockwise is now locked. The FED LED indicates this by flashing. The restart would be possible again if a reset is carried out via the key switch. Now a restart can be carried out with the selector switch. If the sensor input E1 is occupied again, the drive stops. The FAD LED changes from steady light to flashing. Automatic mode is pre-selected by turning the key switch to the left. If the RCP DQ0 for clockwise rotation is pre-selected via the PLC, the drive starts and the forward LED lights up. When the sensor input E1 is activated, the drive stops even if the RC bit DQ0 remains set. The FAD LED changes from steady light to flashing. When the RC bit DQ0 is reset and set again, the drive starts again and the forward LED goes to steady light. In this case, a reset via the key switch is not necessary. When the sensor input E1 is activated again, the drive stops, the forward LED flashes. If no change is made to the RC bit DQ0 and the key switch is set to the 0 position and back to automatic mode, the locked state remains. This is indicated by the FAD LED flashing. A restart would only be possible with an edge change on the RC bit DQ0.